Wow.
So this is called series. Right?
Learned, Oscar.
Right. So each panel you have there is a 5-volt power line. If you got my, so right. Though two will either you can make two a 10 volt or you can make two as a 5 volt. What is the requirement? Because usually there's a requirement to tell you they want a 5 volt power supply or they want a 10 volt. On each case we have 4. So what if they say I want 20 volt power supply? So you gotta do all 4 together in series. So what happened to make it these two together make series to make a 10? Now you got 2 more. So what happened to add more to make a series? A 20 volt. How do you do that? So how do you do to make a 20 volt?
I already know.
So how do you make this a 20 volt if you got 5 volt all the way? What happened to the series? Daisy the plus, this is called daisy change, the minus to the plus, and the plus to the minus, and keep adding on. So what happened to make it a 20 volt? You take this as a negative right there, you daisy change them. See right there, the plus go to minus, the plus on this side go to minus, and the plus go to on minus. So between the 2 poles, you got 20 volts. Right there. Right? Does anybody find something interesting? This is it. Right? So can somebody write me pair all 5 together, make it in parallel and make a 5 volt? How do you do that? Instead of a series, how do you make a parallel 5 volt with 5 power supply? Yeah. No. Those positive, all tied together, and then all negative tied together, and make it 5. Got it right. So where is your light bulb on here? They go across this to get light on. And in this case, we don't have a light bulb, so we're gonna have a resistor. We do have a resistor, don't we? We do have it. Okay. So right here, instead of light bulb at home that lit up, when you got the power cross, put that cross inside your payload. Because assume this is gonna be your computer. Assume this is your computer. So these are power from the panel or power of the computer. That's the whole thing. So sometimes the computer may require 20 volts. Sometimes it requires 5 volts. So you gotta know how to make all your solar. So in this case, you gotta make all 20 volts. So find a way to make this change and put this load on. Okay, at the end, he's going to measure. You're gonna see later on the voltmeter. You can actually, when you put it all together and he sight a light on, you can actually put a voltmeter right there and see a volt from these 5 help.
Oh no, go for that. Yeah, for sure.
Your proxy.
Do you have any question on this?
You can use proxy to put it down.
I have a question. Is that when you were doing the lecture, every time you put these two together, even though it's off.
Yeah, but you're actually shorting. What you're doing is you're actually going past the switch. The switch is actually what's connecting these two.
So what the switch actually does is it have this whole thing. That's your switch. And this is your O and this is your I. Okay, so the electron said this is your light bulb, right? Your light bulb gonna go here, and this is your power, say 20 volt right here. Your minus, which is what is that? Which is what color? Black. So black you don't need to really concern because it have no potential. The plus side you want to tie it to be open. And then this is your switch. So the switch goes like that, right? Normally the switch you want to have it in the open position, right? That that in the open. Now when you close it down, the closed position. So what happened is when you close it down, it provides a straight. So now the electron can move this way to light up the bulb.
Wait,
You guys see that, right?
so it can come out that?
You guys see that, right? So with the 20 volt, you're tied, or a 9 volt battery, you're tied the positive, that's what the positive is. You tie the positive to the switch on the O position, and then the I position will tie to the load, which is your light bulb or resistor or computer or a home, drawer opener, whatever. And then the ground tied to that. So when you put the switch in the closed position, that closes down this circuit right there. Now, if you jump a cable right across over here, you already bypass that switch. That's what you shown earlier. See right there? You have to put in two. If he shorted together, the motor will run. Yeah, because he short the wire from here to here to get the power. So it bypassed this way. That's what you're saying. So the switch is there to close or open the electric flow.
So it's like a door.
Yeah, that's just like a door. When you have, consider you have a wind. A wind can try to blow in your house, but if the door is closed, wind cannot go in. But when you close the door, the wind can go in. So basically, the switch acts exactly like that. Yeah. So you guys have the solar. Oh, you know what? Here my thing. Let me show you. Your purpose is to fold this thing. See, let me have the fairing.